The perimeter of a rectangle is 24 centimeters. What are the dimensions if the area is a maximum? Find the maximum area. Okay, so if we had a rectangle, then if the rectangle had sides, x and y, then the simple equation for the perimeter of this rectangle would just be 2x plus 2y is equal to, and we actually know the perimeter, so it's going to be 24. Okay, now to make life a little bit simpler, why don't we just divide everything by 2? So divide each term by 2. So an even simpler equation would be x plus y is equal to 12. All right, now I'm going to leave that for a second. And we're going to focus now on maximizing this area. So what would the equation be for the area of this function? Well, the area would just be this. It would be a, this time I'm going to write a of x, write it as a function. So a of x is equal to, and then x, y. All right. Now we want to maximize this area. So what I want to do is I want to take the derivative of this and set it equal to 0. So same problem as we had in the last one. I can't really take the derivative of this when it's in terms of x and y, right? So what I'd like to do is I'm going to use this other equation that we already made and have it all in the same terms. So let's do this. Let's rearrange this one for y. So we'll say y is equal to, so we'll bring the x over, so we get 12 minus x. So there you go. So now if y is equal to 12 minus x, then what I'm going to do is I'm just going to replace my y with 12 minus x. So let's do that now. So we'll say a of x is equal to x times, and then this was 12 minus x. Okay, now from there, let's expand it just so it's a little bit easier to take the derivative. So a of x is equal to, and this would become 12x minus x squared. Now this looks pretty straightforward for taking the derivative, so let's do that now. So a prime is equal to 12 minus 2x. So if we're going to maximize this area, then what we want to do is we want to have our derivative equal to 0. So that's where our slope is 0, right? That's going to be our vertex if you graph this thing out. So 0 is equal to 12 minus 2x. And then some straightforward derivative here, or straightforward algebra, sorry. Here we get x is equal to 6. All right, so that's the value of x that's going to maximize this, and then I just still need to find my value for y. But this should be pretty straightforward. We actually already made an equation for y in terms of x. So my x is 6, and then here I will just actually put in, so 12 minus 6, so y is also equal to 6. Turns out that the best way to maximize the area would be to make it a square, right? Both 6 and 6, which kind of makes sense intuitively, doesn't it?